Hello friends, in this video we are going to discuss about the first basic operation associated with matrices, which is the addition of matrices. Okay, now for two matrices, okay, let's say two matrix A and B. If they are to be added, okay, they are eligible for addition process if both of them have the same order. Okay, let's say the matrix A has order P cross Q and matrix B has order R cross S. P is the number of rows of matrix A, Q is the number of columns of matrix A, R is the number of rows of matrix B, S is the number of columns of matrix B. So, for A and B to be added, the only condition which they need to uh, fulfill is this: number of rows of matrix A should be equal to number of rows of matrix B, and number of columns of matrix A should be equal to number of columns of matrix B. They should be of the same order. They should have same order. Okay, this is the only basic condition which the two matrices or any number of matrices which are to be added, they need to fulfill. Okay, let us start with a simple addition of a 2 cross 2 matrix. Let's say this is one matrix and another matrix, let's say okay. Now these two matrices, they have order 2. They are square matrices of order 2, that is 2 rows and 2 columns. So they can be added. There they satisfy the condition for addition of two matrices. So let's say this matrix is A and this matrix is equal to B. So A plus B will be 1 plus 2, it will be 2 plus 4, it will be 3 plus 6, it will be 4 plus 8. So here the addition of two matrices is done element by element, term by term. It means this element which is at the position A 1 1, okay, that is at the intersection of the first row and the first column, gets added with the corresponding element at the same position of the other matrix, that is B11, which is also present at the intersection of the first row and the first column. Okay, 1 plus 2, 1 gets added with 2, the respective element in the same position. Similarly, 2 gets added with 4, this is, let's say, A12, which is present at the intersection of the first row and the second column. It gets added with 4, which is also present at the intersection of the first row and the second column of matrix B. Similarly, A21, 3 gets added with B21, 6, and A1, this is A22 and this is B22, 4 plus 8, they get added, okay, which is present at the intersection of the second row and second column in matrix A, and here it is also present at the intersection of the second row and second column in matrix B. So respective elements are added with respect to each other, 1 with 2, 2 with 4, 3 with 6 and 4 with 8. So this result will be, this is 3, this is 6, this is 9 and this is 12. This is the result of the addition of the two matrices. Okay. Similarly, if we take a 3 cross 3 matrix or any matrix of any order. Okay, let us consider a 3 cross 3 matrix. Okay, so 1 2 3 2 1 2 1 1 2. Okay, this is one matrix, let's say A, and another matrix, let's say B, is equal to 2 4 1 1 2 2 and 1 3 1. Okay, these two matrices. Now they are eligible for addition because they have the same number of rows and columns. Okay, this is a 3 cross 3 matrix and this is also a 3 cross 3 matrix. So for them to be added, the respective elements which are present at the respective positions have to be added together. Here this 1 which is present at the intersection of the first row and first column is added with 2. This 2 in matrix A which is present at the intersection of the first row and second column gets added with 4. Okay, this 2 with 4. This 3 which is present at the intersection of the first row and the third column will be added with 1, which is also present at the intersection of the first row and third column in matrix B. So like that it will happen. So the resultant matrix will be, let's say, A plus B is equal to A plus B is equal to 1 plus 2, 2 plus 4, 3 plus 1, 2 plus 1, 1 plus 2, 2 plus 2, 1 plus 1, 1 plus 3, 2 plus 1. Okay, this will be the resultant matrix and this value will be 3 6 4 3 3 4 2 4 and 3. Okay, this is the result. Okay, let us say we have two matrices of this type. This one, as you can see, it is a column matrix. Okay, there is only one column and 3 rows, and here these two are row matrices which having 1 row and 3 columns. Okay, so if we want to add these two matrices, the result will be the respective elements are added. So it will be 1 plus 1 is 2, 2 plus 0 which is equal to 2, and 3 plus 1 which is equal to 4. Okay, 1 gets added with 1, 2 gets added with 0 and 3 gets added with 1. We got this result. Similarly, here this one will be added with this one which is present at the respective element, respective position. Okay, intersection at the first row and first column. This one will be added with this element 2 which is present at the intersection of the first row and second column, and this element which is present at the intersection of the first row and the third column will be added with 1. Okay, so the result will be 1 plus 1 2, 1 plus 2 3, so 2 plus 1 3. Okay, 2 3 3. So this is how the addition of matrices is done. Okay, let us consider the addition of these matrices. As you can see here, it is a 2 cross 2 matrix, and this is a 1 cross 2 matrix, 1 row 2 columns, say 2 row 2 columns. This is a 2 cross 1 matrix, 2 rows 1 columns, and this is a 1 cross 3 matrix, 1 row 3 columns. This is a 2 cross 3 matrix, 2 rows 3 columns, and this is a 2 cross 2 matrix. As per the law of matrix addition, two matrices are eligible to be added if they have the same order. But here, the matrices which we want to add, they have different orders. They have different number of rows and columns. So these matrices cannot be added. Okay, these type of matrices cannot be added because the order of the two matrices which we want to add, they are not equal. Okay, so we cannot add these matrices. Okay.